Welcome to our deep dive into Angular's architectural backbone. Today, we are exploring the sophisticated mechanics of Angular modules. Forget the notion that they are mere folders. They are the compilation contexts that define the very boundaries of our application logic. Let's begin. We start with modern Angular modules. In enterprise applications, a flat structure quickly leads to unmanageable spaghetti code. Modules solve this by enforcing highly structured architectural boundaries, defining an isolated scope where dependencies are explicitly registered. The core app setup is where we connect the abstract framework logic to the host environment. This foundational layer handles browser integration before any specific business logic executes. Keep it strictly minimal to ensure the initial load remains highly efficient. Specifically, we rely on the BrowserModule. It acts as the crucial bridge connecting the framework's rendering engine with the browser's native DOM. It provisions critical services like the DOM sanitizer to ensure secure parsing. Importantly, import this exclusively once in your root module. During app bootstrapping, the platform browser dynamic function compiles the root module and searches the index HTML for our root component's custom selector. This kickstarts the entire component tree, establishing the foundational memory context. Notice how we abstract DOM manipulation. Modifying the document directly via global browser APIs destroys platform independence. By utilizing the framework's renderer 2, we guarantee compatibility with server-side rendering and ensure the view stays perfectly synchronized with component properties. For single-page navigation, we centralize logic in the AppRoutingModule. It intercepts the HTML5 history API to update the address bar without server reloads. Always append a wildcard route at the very end of your configuration to gracefully catch invalid URLs. To scale gracefully, we implement a lazy loading setup. Downloading the entire codebase upfront severely penalizes user load times. The build tool automatically splits our code into isolated chunks, seamlessly fetching them over the network only when a user navigates to that specific domain. This relies on the root configuration, established via the router module for root method. It acts as the global registry for all top-level paths. You must invoke this method exactly once to construct the primary navigation tree properly. Modern software requires robust data communication. We completely isolate network logic from visual components. Centralizing asynchronous requests inside dedicated service classes guarantees a clean separation of concerns and significantly improves unit testability. We achieve this via the HTTP client module. Imported strictly at the root level, it provisions the HTTP client singleton. This modern API completely replaces legacy implementations and natively integrates with reactive streams. Because network responses are unpredictable, we treat them as observable streams rather than static promises. This reactive architecture allows us to mathematically transform incoming data packets or cleanly cancel pending requests, avoiding severe memory leaks. To manage traffic globally, we use HTTP interceptors. They act as transparent middleware between the application and the browser network layer. Registered sequentially, they can rigorously inspect and modify HTTP streams without altering the underlying component logic. A practical use case is request modification. Since request objects are immutable by design, the interceptor creates a deep clone. It safely injects authorization tokens into the headers before forwarding the modified clone down the execution chain. Similarly, for error handling, interceptors evaluate incoming responses backwards through the middleware chain. Catching a non-200 status code allows us to gracefully process server failures globally, such as instantly redirecting expired sessions to a secure login prompt. For global application state, we utilize core singleton services. By applying the provided in root syntax directly within the service decorator, the dependency injector securely caches the service upon its first instantiation, maintaining a strict single source of truth. The dependency injection system dynamically resolves and supplies these instances via component constructors. Never instantiate external classes using the new keyword within your framework code. Doing so completely breaks the injection system and tightly couples your architecture. For state management within these singletons, we expose read-only observable streams. The underlying RxJS behavior subject actively holds the latest data snapshot in memory, forcing scattered components to react continuously to state updates without explicitly polling. Moving to user input, form management is a highly complex requirement. While simple template-driven forms exist, enterprise business logic demands a programmatic approach to maintain strict structural control over the state. We therefore rely on the reactive forms module. It completely bypasses implicit template directives, explicitly requiring us to instantiate form control objects manually. This guarantees synchronous access to form data and makes the validation status highly predictable. To construct deeply nested groups efficiently, we inject the Form Builder service. It provides a streamlined factory mechanism that acts as highly optimized syntactic sugar, drastically reducing boilerplate when initializing large component structures. When standard constraints fall short, we write custom validators. A custom validator is fundamentally a pure mathematical function evaluating an abstract control. Storing these in isolated files ensures they evaluate values reliably across entirely different feature modules. Robust form validation prevents malformed data from compromising the backend. The framework continuously evaluates a chain of registered validation functions, accurately flagging the internal programmatic model as invalid and dynamically updating the native DOM classes. We utilize sync validators for immediate evaluation. Executed instantly upon every single value change event, they provide crucial, instantaneous visual feedback on basic constraints without generating slow and unnecessary backend traffic. For complex backend checks, we use async validators. They execute dynamically only after synchronous rules have successfully passed. Returning an observable stream, they safely mark the control as pending during the necessary server round trip. As the code base grows, we implement feature architecture. Pushing all components into a single root registry creates an unmaintainable monolith. We logically segregate code into discrete, highly manageable functional areas grouped by business domain. These domain feature modules act as strict, impenetrable sandboxes. Unless explicitly exposed, everything inside remains strictly private. This encapsulates internal implementation details and drastically improves long-term project maintainability. Inside these modules, the declarations array registers local views. An element can only ever exist in exactly one declaration array across the entire application. This establishes a highly private compilation scope and prevents catastrophic compiler collisions. To establish a public API, we utilize the exports array. By exporting only the top-level container components, we allow external templates to safely render specific elements while keeping the complex internal component tree completely hidden. For purely visual consistency, we centralize reusable elements in share modules. Any feature module importing this hub gains safe access to generic tools. However, never provide global singleton services here, as lazy loading would dangerously spawn duplicate instances in memory. Every feature and shared module must import the common module. Foundational directives like ingIf are not globally available by default. This explicitly injects basic template logic into the local context without unnecessarily reinitializing heavy global services. Finally, we decouple navigation using feature routing. By utilizing the forChild method, we generate isolated routing trees that strictly map internal URLs to local components. This seamlessly integrates secondary route definitions without overriding the global router singleton. By strictly enforcing these modular boundaries and reactive patterns, we guarantee that our codebase remains highly performant, scalable, and fully maintainable over years of development. The architecture dictates the success of the software. Thank you for your attention.